while ago, I reviewed this LR7 quad from iFlight on the channel. As you can see, it's a long-range 04 based FPV quad, and in the review, I used it with LiPo batteries. However, to get the best from this quad, you're going to want to use lithium ions. Now, I have struggled to actually find good lithium ion packs in the UK in the configuration and the size I want. iFlight do make their own pack, but I haven't found anyone who actually sells it. So as a result of that, I decided to go on a journey and we're going to make our own. Now, a little while ago, I bought the Kweld from Klab. It is a battery welder, and I've done a review on that already. I've been talking about making batteries on my Discord for quite a while, and we've talked about it in live streams. I've ordered in a bunch of 21700 cells. So what we're going to do in this video is make my very first battery. Now, this isn't a tutorial. Please understand that this is the first time I have ever made a battery. I'm going to share with you my experience going through the process of putting a pack together. I'm not going to pretend this is perfect. I'm not going to pretend this is how you should do it. But at the very end, hopefully, and I say hopefully, we will have a battery that we can use. And what I'm going to do is show you how I get on. Now, before we get into this, I just want to put a bit of a warning up. I said something earlier that actually isn't true. I said I'd never made a battery before. I've made loads of batteries in the past. What I've never done is built a lithium ion pack for FPV. I, though, understand the risks of working with batteries. They are dangerous. Get something wrong, they can or will cause fire. They could explode. Please only do something like this if you understand the risks. These types of cells hold an incredible amount of energy, and they can cause an incredible amount of damage if something was to go wrong. So please, it's not a tutorial. Take care. If you're going to do it, make sure you understand the risks before proceeding. Okay, so this is the plan. We are going to make a 6S, so 6S2P lithium ion pack based on 21700s. I went for the P50Bs, I should say. I've had these a little while now. I've done a few videos on getting to this point. And what I'm going to do is put together my first pack. Now, as I've said, this isn't going to be a tutorial. I may get things wrong in this video. I am certainly not an expert at making batteries. I've spent tons of time talking about this on my Discord group. Loads of great guys there. I finally got in pretty much everything I need to do it. So we've got the cells, we've got the nickel strip, we've got the protection pieces for the top of the cells as well. And I have a huge roll of, well, different rolls of heat shrink tubing. And whilst I haven't had in all of the balance connections I ordered, I've got one which I've cut up, which I'm going to use for this first pack. Now, the configuration I've decided to go with on my first battery is this one you're seeing here, which is going to be like that. Obviously 6S, so the series element is along each row. So positive, negative, positive, negative, positive, negative. And then we have that paralleled up along the side. And then what we're going to do is weld these together. We are not soldering. I did a review on the Kweld, and we're going to be using the Kweld here today. If you're interested in seeing that video, go check it out. I'm not going to talk too much about that. My plan is to use the 0.15mm nickel strip, which is this here. I've got two different thicknesses, I think. They're both genuine nickel. Let me just check these, because I think I've got a 0.15 and a 0.20, but let's just check that is correct. So this one here, if I get my vernier on it, is, that is not zeroed properly. There we go. That's showing 0. There we go. If we go, that must be the 0.5. And I also then have this other roll here, which I'll get out. This feels heavier. I suspect this is the 0.20. if I push on it, it's 0.15. What's it say on the pack of this one? So this one is... This one doesn't actually say the size, which is interesting. Whereas this... So this one, which is that one there, says 0.15 8mm. So this must be the 0.20. Now, I was originally going to go with the 0.15. I know the 0.20 can be quite difficult to weld. I haven't quite decided fully what to do. Let's try with the 0.20. Let's go down that route and see how we get on. And what my plan is to obviously strip. This is just a quick piece I've cut as a demo. We're going to strip obviously from there to there, and then on the bottom side we'll come across from there to there, but we'll do that after. So the plan will be there to there, 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 and then I need to cross-link, which I will do there to there, there to there, and I'll double cross-link, and then double cross-link and double cross-link to give us our parallel, and then flip the pack over and do exactly the same on the other side. Now, the next thing we're going to need to do is install these. These are felt strips for the top of the batteries, and what these are for is to stop the nickel strips cutting through the heat shrink tubing that's around the top and shorting the battery out. Remember, the outside of the battery under the shrink tubing is negative, our ground, and then our terminal is in the middle there. But there's a risk with these strips on here that over time that they can cut through. So what you do to get round this is install these little felt rings around the top like that, and these go on to the top of each battery, and then when we do our welding we would weld like that, and then it offers some additional protection in the event of any movement in the pack itself. So I need to go and do that on all of the batteries. I won't sit here and show you me doing that. I'm going to pop off and then I'll be back when they're all done. Now, for this today, we're going to be using my Kweld. I have a video on this, as I've already said. This is a very good piece of kit. We're going to be doing the welding with this. We're going to go with the 0.20. We're going to have a bit of a play to see how this gets on, how much power we're going to need. I may even waste a cell in doing that or two. I've got plenty though, but that's what we're going to be using. I've got a big battery for that here as well. And as I've said, I think we will go with the 0.20 strip. So I'm going to cut that into a few pieces pre-length now as well. So again, I'll go and do that off camera and come back when all of that is ready. Okay, so I think I got enough strips to get me going at least. Now, to keep these batteries in some form of order, I'm going to use some boxes. Now, this probably is far from the best way of doing this. These are some boxes for the Era FPV frame. There'll be a video coming about these at some point. But that there sort of has allowed me to align the cells up. And then, as I've said, the theory is with this, what we will do is weld from there to there and weld from there to there, and then we will parallel up from there to there and there to there, or maybe even parallel up in the middle as well to give some additional current carrying capacity. Now, I'm not using any copper in this pack. There is a lot of opinions on if you should need copper, do need copper, whatever it is. We're going to go for straight nickel on this one, and then we'll see how it performs in the real world once we've done it. Okay, so we have the Kweld. We have everything set up. The next question really is, how much power are we going to need? I've currently got it set to 35. But I think we're going to need more like 50 for this, based on the testing I did before. So I think what we'll do is we'll get our first strip ready, which is going to be there. And we'll do a test on the first one to see how this goes. I'm just looking for my pedal. I think what might be easier is to tack to the bottom of that cell there first of all. Let's have a go. What did we get on that? Let's have a look how much power. 1100 amps. Okay. That has definitely welded. If I now bring it in a bit closer, it's quite hard to show you with the light reflecting off the top of these cells. One moment. Okay, so I've tweaked my lighting situation. You should be able to see things a little bit better now. I'm going to jack the power up a bit more to 60 joules because I'm not 100% happy we got enough in on that. So what we're going to do is get ready. I'm going to go in here. That looks like a pretty good weld. Less on that one. How much current did we get on that? 1157 amps. I actually think I'm getting to the limit of what my battery can provide on current. So let's get that in there. We've got a few welds on that one now. I'm just going to do another 2 there. There we go. I'd like to think, it's certainly not the tidiest pattern, but I'd like to think that should be enough. So let's get over onto this battery. Let's rotate and get ourselves set up exactly where we want it. There we go. Right, let's go. Oh, that felt like a goodie. We're getting a good spark on him. I'm going to go 6. I'm just working my way down. There we go. 1100 amp on that one. Getting some heat in the probes, actually. So, I think we've got a bit there. I'm not 100% happy on this one. I might tack a few more on that one in a minute. But also, we might be welding over the top of that in a minute as well. So, like as an example, I want that down there and that there. So let's just do a tack on that corner there to get that down. There we go. So I'd like to think we've got a bit in there. I seem to be definitely hitting the limit of what my battery can provide on this. I'm using a very big lead acid battery, as you saw there. Certainly not the perfect solution. I'd like the capacitor bank for the welder, if I'm honest. I think the capacitor bank would be very cool to have. Okay. I'm just a little unhappy. That's got a bit of a rise on the edge of that one. Let me just try this one. Oh, that feels a bit better. How are we on that? That's perfect. Okay. So, let's get ourselves where we want. So, we'll start on the other cell on this one, I think. So, we're going to get in and go down. There we go. Let's go for 3. There we go. So we've done 3 welds. I'm going to do a couple in the middle as well. Okay. They don't feel... I hope the penetration is good on them. I don't really want to sacrifice a cell to confirm 100%, but I have done testing on batteries in my other review. I think we're okay. So now we can continue. There we go. And I'm going to do another row down there in a moment as well. I'm just going to let the battery recover a second, just to, and also make sure that the welder has recovery time too. I might see it. I'm going to up the power a bit more. I don't think it's going to make any difference because I think I'm at the limit of the battery is what I'm at. But let's see. Press down. I'm just keeping an eye on the welder to see what it delivered. Yeah, 1100 amps. No matter what I'm doing, I'm now hitting the limit of what the battery can supply, which is a shame, but we're getting there. There we go. Certainly not the tidiest in the world, but we've got those two cells now in series. And then what we will then need to do is do those two, and then those two, and then flip it over and do the same, and then carry on forward from there. But what we then also need to do is then start paralleling up, and I want to start looking at that now as well. In the ideal world, what we want to do is parallel up like that there. And then, it's a bit long, that one. There. So to allow as much capacity, it does make you wonder if it would be better having it in the middle, but the idea of it paralleling up obviously here on top of the existing welds is you're also punching in directly into the battery. So let's give this a try here. Let's see how we get on. Let's tack one in there. There we go. Down into this corner. Our probes are definitely getting hot. There's some heat in these now. I'm just going to hold down to see how much current we're putting in. Still 1100 amp. So there you can see we've cross welded across there. It's definitely on. It's definitely not coming off. That's for sure. And then the idea is we will cross weld across to there. I will need to press this down a bit more and tidy it. Let's get on the edge. So we want to be there. Pushing then our nickel down. Nickel is very soft, so we can get in there. one up on that edge there, one on that edge there. There we go. So there we've cross-braced that on top of the existing welds as well. So we're welding even potentially back through and down into the battery to give us our current carrying capacity. And then again, we're going to want to do the same up here. Exactly the same process. Unfortunately, I didn't buy the strip that does this in fours, because you can buy this strip that does this in fours, so you don't have to do this crossing that I'm doing here with the welding. That will be the best strip to actually buy, because that will do it all for you. Again, so let's start over this side this time, I think. Pushing through to try and make sure that we get as much of a weld in there as I can. Man, these probes are getting warm. Here we go. So hopefully we've got plenty into that one. And then we need to simply do the same again across here. Okay, so that is our first set together. If I just move these along a minute, I can show you this in a bit more detail. It would have definitely been easier if I'd have had the already four-crossed stuff rather than the single strips like I have got here. It definitely would have been easier if I'd have been able to just lay it across, and then we'd have just gone dee-dee-dee-dee-dee-dee-dee-dee-dee-dee-dee-dee. However, I'm fairly happy with that, if I'm honest. Yeah, I don't think that is too terrible at all. Now, obviously, if I spin this over, we do now need to sort out some stuff with these, first of all, because these don't link the same as the top, but these two do link together. So I need to link these two together, but that then links on to the next cell. So I do need to link these two together with a piece along the bottom. So that's what I will do next. There we go. That's the one done. So now I need to just get that there. We just need to get a weld on here to make sure we've got it where we want it. There we are. We just need a tack weld at this point. Like that. Here we go. So that holds that all in place. So I just then need to do the same down there. Okay, so next we need to bring in our second set of cells. However, we don't weld this way. We need to flip over like that. Flip over like that. And then basically replicate the same thing again, which is bringing our box in, bringing our cells in nice and tight into that corner there. And then now it's a case of across, across, just like we did before with the 2 metal strips. And then the same with cross-linking, exactly the same as we did earlier. Okay, so I have got to this stage here. I'm going to stop for a little bit because my battery is starting to struggle, as well as my probes are getting too hot to hold. So if we hop back to here, this is where we started. So what we've done is welded across, 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 across. Then we flipped it over, welded across, across, across. I do need to weld another one across there in a moment. I haven't done that yet. It's on my list to do next. And then we're ready to pair up to the next pair of cells, which will be like this, to go there, across to there, because we are coming down from above there. Now, I have got some fiberglass tape around this, just trying to hold this in some form of sort of position, but we are getting there. It is quite a slow process, simply as a result of having to wait for my battery. The K-Weld's holding up well, but this big lead acid battery that I'm using isn't enough. It's not enough. I really could do with a capacitor bank for this, but we're getting there. Slow progress. What I think I'm going to do now is stop for an hour, put the battery on charge, put a bit more power in it, and then come back and carry on. Okay, so the pack is essentially done from a configuration perspective. Obviously, there's all the balance wires and everything to be done and the wrap and all of that, but it is built up. If you remember, we started over here. So we have our negative terminal, which is going through to our positive, into our negative, out of our positive into our negative, out of our positive into our negative, across, all the way back down up to the end here. So in theory, we should have 6S voltages on this right now because everything is parallel up. We have our negative over here and our positive over here, and what we should have is 21 volt, which is nice to see. That is our full pack voltage. It's not fully charged, so it's sitting at 21 volt, which is good. So the next thing we need to do is look at doing our balance cable. Now that's going to have to be soldered, and then looking at our main battery output before getting it all heat shrunk up. When it comes to our balance cable, this is going to be fairly straightforward, but what we're going to need to do is just do this in such a way that everything will reach. Shouldn't be too bad to do. Obviously, we're going to have one here, then one over here, then one over here, and then back forth all the way through. We're going to need to solder with these, and we're going to have to watch what we like with the cable lengths. The negative one isn't particularly the hard one to do. That one can go to there, but it's then what happens with the others that have to go down into the pack. These are the ones. So for instance, this one actually has to go down to the bottom of the pack down here, because that is to the output of there. So what we're going to need to do is just make sure that there is enough length. There is space to bring that up on the side there, which is okay. I'm actually probably going to start with this one and then trim the negative afterwards, because there'll probably be a bit much on that after we've done it. We'll start with this one and then I'll work our way through. Hopefully, if I have done this right, and I've gone down the sides with the wires because I'm a little short on length on this cable, but if I have done this right, we should have a correctly wired balance plug. So let me just grab a tester. Let's plug it in to this one, and then we will see how it goes. I'm just trying to remember which way on this one's negative. Oh, there we go. Couldn't see it initially. Boom. There we go. We have each of the cells showing. 3.52, 3.51, 1, 3.508, 3.51. All looking good. So the last thing for me to do is now solder on a full set of output cables, which are going to come along the top. So we need the big one to come along here, and then the other one to come along here as well. I've now finished all of the soldering. Yes, it's a bit of a mess, but it's not too bad. If I was going to do this again, I would put all the cables down the middle. If I had a balance cable that was long enough, I didn't, so I had to use this one. But everything is now connected. What I need to do next is tape all of this up. I also want to put like a bit of foam or something along the bottom here. I haven't really decided what I'm going to use. I'm going to tape this up a little bit as well with the fiberglass tape. Some foam just to add a bit of sponginess. before we actually put it all into the heat shrink tubing and then have a look at what it looks like. Now, before I heat shrink this up, I thought I'd show you what I've done. I have some foam from an iFlight quad box is where it came from. It's the foam that sits along the top when you open it up. I've placed that on the top and the bottom as a bit of an insulator. I've wrapped more tape around it. That's all really bundled the pack up nice and solid. What I'm just going to do now is trim these little corner pieces off with a pair of scissors, and then we will get it into the heat shrink tubing. And ta-da! There it is. Now, this is my first shrink wrapping as well. I left a bit too much on the end and I've cut it off, and it has opened it up a little bit. I might actually second wrap this just to try and do it a little bit tidier, but as a first attempt, I'm fairly happy with it. There it is. We have a full-size 6S 2P lithium ion pack. It's not light, I can tell you that. P50Bs. Weight-wise, let's have a look at what it's coming in at, because it is a chunk, that I can tell you. Okay, so I've got me scales. Let's pop it on. 892 grams. I'm pretty happy with that. Right. That's it. All done. Okay, so this is the quad that I intend to be using this battery on. This is the iFlight LR7. I did a review on this a little while ago with lipos, but this quad will take a big battery. I wanted to try and get my hands on the iFlight Send massive lithium ion, but I couldn't get it in the UK. So in the end, we made our own. Now, as I have said earlier in the video, this isn't my preferred configuration. I also want to try and make one that is 3 series, 2 parallel. So you're going to have 6 batteries, 3 and 3, and then 3 and 3 stacked on top. That is a better configuration for a quad like this. This isn't terrible. If you see it does stick out. You're not going to be able to put this one so it's vertical because there's a bit of foam on the bottom. That is not going to be ideal. But in the horizontal, it does stick out over the side, but it doesn't catch the props. The props are fine. They are below it, well below the battery, so it does fit on a quad like this without any issues. But I am looking forward to be able to make in another one, and I'm going to do a video on that one again as well. Yes, as I said at the start of this video, this was never a tutorial. This was my experience. It was never the best way to make a battery. There are probably people going to put loads of comments in saying, you did this wrong, you should have done this, you should have got the 2P nickel strips, that makes your life easier, you should have done it this way and that way, you should have soldered, whatever. I know I am not an expert at making batteries. What I wanted to share with you was my experience doing it, and I am really pleased. I'm really chuffed with how it's come out. I know it's not perfect. We need to sort of get some plastic covering for the sides there. I need proper longer balance cables. The way I did the balance cables wasn't perfect. I know this stuff, but for the first attempt, I'm really, really happy. Something I will give you some advice on is this stuff, which is the fiberglass tape, is phenomenal. It adds a lot of rigidity to the pack. If you're making batteries, get yourself some of this fiberglass tape. It really does help. Now, just to talk a little bit about the Kweld that I used, because I have reviewed it, but I have a few different opinions, having spent a lot more time on it on certain aspects. I still think it is a phenomenal tool. Something I hadn't picked up in my initial review is how hot the probes get when you're making batteries. I did testing with it, but I didn't do a lot of it in a row, and I didn't notice just how hot they get. I'm going to print some TPU covers for mine because it gets to the stage where you can't hold them anymore, even though they've got some silicone over the top. Further to that though, I am also struggling with getting enough power into it for those 0.20 welds. It will do it, but I would like a bit more bite into the weld. It's because I'm using that big lead acid battery that I talked about. The problem I sort of have with this is, and it's really interesting because this is really poignant right now. The Kweld is a German-built, very nice welder. Really good. You can use it with batteries, but they also make a capacitor bank for it that allows you to get the most from it, deliver the most power, rather than have a big battery on the side. When you look at the cost of that, though, the Kweld on its own is quite expensive, about 169 euros. Quality piece of kit. I am happy to pay for quality gear. But if you then add in the cost of the capacitor bank as well, you are looking around 400 euros for that kit in total, especially when I add in import fees into the UK, because I paid quite a lot on the import of the Kweld. There are, though, other options available on AliExpress. There's the Glitter one, which is the 801H from Glitter. But that comes in around £200, £220 delivered, including VAT, from AliExpress. And this is really poignant because this all plays into this, what's going on in the US right now. We want made in America, we want made in Britain, we want made in Europe, not China. And this is a great example of the price you will pay, because the Kweld is a very, very nice piece of kit. But you are paying for that. And you can literally get a Chinese-built unit for half the cost. And it's really hard to justify the Kweld when that's the case. And I haven't tested the Glitter. There are a lot of good reports about it. I'm sitting in this weird situation now where I've paid for the Kweld, but I might really need the capacitor bank. But by the time I spend more money on the capacitor bank, that capacitor bank is the same money as ordering in the Glitter unit, which is everything in one, which has a built-in capacitor bank with it. So do I spend the money on the capacitor bank and then make the Kweld as good as it can be? Or do I spend the same money and get a second welder and then just continue to use the Kweld on this battery? Or even if that's good, just use that and sell the Kweld. It's a hard one. And again, this is exactly the problem people face when we sit here and say, I want made in my country. We all want made in our country until we have to pay for it. And that is an interesting one. Now, that's it on this video. I really hope you have found it interesting. Please do let me know in the comments section. Any questions, put it down there. Finally, I just want to say, if you'd like to support the channel to allow me to keep doing things like this, because this isn't sponsored, this isn't paid for anyone. I bought the Kweld, we bought the batteries. All of this was bought to be able to show you guys this, but also make batteries and talk about it on the channel. If you'd like to support us to allow us to keep doing this in the future, please do consider checking out the links to my Patreon, as well as buy me a coffee. It is only through the support of my patrons can I run this channel. We do work with manufacturers and we do receive some stuff for free, but we do not receive everything. We pay for a huge amount of gear here, and as a result of that, it allows me to be able to remain independent, say the things I want to say without any fear of retribution. Those who watch the channel regularly will know what I mean on that one, especially recently. So if you'd like to support us, please do consider checking it out. I want to say a huge thank you to all of my Patrons as well. All of you, everyone who donates. We would not be able to do this without your support. A huge thank you from me. So that's it from me. Let me know what you think below. Stay safe. I will speak to you soon.